Hello everyone, we are Group 8 and our project is the Chicago Delivery Database System. Chicago is a student-run company that handles package deliveries across campus and nearby areas. We identified that manual tracking of customer orders, staff assignments, and payment statuses led to inefficiencies and data loss. Therefore, our goal was to build a database system that would organize and automate these operations.
Chicago's logistics system was designed through a structured analysis of its operational needs, resulting in an entity relationship diagram that clearly maps out entities, attributes, and key relationships. This model supports smooth management of orders, packages, customers, drivers, and payments. At the core is a user entity which stores basic personal information and serves as the foundation for two specialized roles. We have the customers who places orders and the staff who handle operations and can also serve as drivers when assigned delivery tasks. Staff members are then grouped into departments to help organize workflows. The system's main components are orders, which capture transaction details. We have packages which track physical items, and we have payments which handle financial records. These are all interconnected. Customers initiate the process through a places order relationship, forming a one-to-many link with orders. These orders are then assigned to drivers via the assigned to driver relationship, ensuring clear accountability. Each order is also tied to a payment through a mandatory one-to-one mixed payment relationship to maintain financial integrity.
From our ER diagram, we derive our relational schema. Tables like orders, packages, customers, staff contain all necessary attributes. We ensure normalization up to third normal form. For example, the table has foreign keys for package ID, customer ID, and payment ID, reducing redundancy and enforcing referential integrity. Each related table uses a user ID as a key to prevent data duplication.
Hi, I'm here to take you through the Python backend of our electricity delivery service. So first, let's look at the get database connection function. The get database connection function establishes a connection to our SQL database file called ChicagoDB. After connecting, it runs the SQL command pragma foreign keys on. This line ensures that foreign key constraints, like making sure that orders reference valid users, are actually enforced by SQLite, because by default, SQLite does not enforce them unless this is set. If anything else goes wrong while trying to connect, the function will catch the error and print it. Now, we have another function, setup database. This function sets up all the tables from the delivery app. Here's what happens. You connect to the database using the get database connection. Then it executes the multiple create SQL statements for all our tables. So tables such as user, staff, payment ID, customers, and the likes. For example, the user table includes fields like user ID, full name, email, password, and role, and sets user ID as a primary key. Then there are child tables like customers and staff, which reference user ID as a foreign key from users. Some tables like orders reference customer ID, driver ID, and payment ID. The onDelete rule defines what happens when reference records are deleted. For instance, you might use onDelete set now, so a deleted driver doesn't break the order record. Now, let's move on to the insert user function. The insert user function is used to add a new user to the database. Here's how it works. First, it checks if a user with the same user ID or email already exists in the database using a select query. If it's not, it uses an insert into SQL statement to add the user to the user table. Depending on the user's role, if the user is a customer, it adds their phone number to the customer's table. If it's a staff, it inserts them into the staff table, making them to a department via department ID. Now, we also have the get user by email password. This function is used during login. It takes an email password, then uses a select statement check if it matches a user existing in the user table. So select from where user is the email and password. If it finds a match, it returns useful user info like their ID, full name, role, and email. If it's not, it returns none. This is how authentication works in this system. We have the insert order with payments. This function handles inserting a complete order transaction, including the payment and all related packages. Here's what it does. First, it inserts a row into the payments table with amount method and sets the status to pending. It uses Keza last word to get the new payment ID. Then it inserts a new order into the orders table, linking it to the customer ID, the optional driver ID, and the new payment ID. Finally, it loops through all the packages passed to the function and sets one into the packages table, referencing the new order ID. So this function uses three insert functions and links them together using foreign keys. We also have the get all orders details. This function is mainly for administrators. It fetches a list of all orders with extra info from multiple tables. The SQL used here uses joins on orders, user, and payments tables. Then for each order, it does another query to get a list of related packages using the order ID. The result is a full summary of who placed the order, what's they ordered, how they paid, and what the packages were. Then we have the get user orders details. What this simply does is that it takes the user ID of the user and then does a join between the orders, user, and payment tables. And then for each order, it's again retrieves related packages using select query, similar to our previous function. Now we have the last function we have is update order status. What this does is that it takes an order and then updates it to pending to completed. Where the customer can see that okay, the package is ready. Thank you.
In conclusion, a database system helps Chicago manage deliveries easily and more efficiently. It keeps track of orders, customers, and payments in an organized way. So some of the challenges that we encountered throughout this project was fixing SQL queries and setting up relationships among the tables, but through teamwork we were able to rectify them. Looking forward, we plan to add an automated delivery process like an Uber delivery system instead of admins finding available drivers to pick up orders. Thank you.